Hello dear friends, welcome back and good morning. Today I have come with a new video, and in this video I am going to solve this question. And the question is, if sin x is equal to m sin y and tan x is equal to n tan y, then prove that cos square x is equal to m square minus 1 upon n square minus 1. It's a problem of trigonometry. Now without any delay, let us begin the solution. In the question, it is given that sin x is equal to m sin y and tan x is equal to n tan y. And using this, we have to prove cos square x is equal to m square minus 1 upon n square minus 1. Now, to prove this, we can use both the relations, the first relation and the second relation, to prove this part. Here, it is given by the question that sin x is given by the question that sin x is equal to m sin y and tan x is equal to n into tan y. Now we can simplify the second part, tan x is equal to n tan y, and this gives, for tan x we can write sin x upon cos x in the right hand side, n into, for tan y we can write sin y upon cos y, because sin theta upon cos theta is tan theta. Now we can substitute for sin x m into sin y. From here, we're going to substitute sin x by m sin y. So it becomes m sin y upon cos x is equal to n into sin y upon cos y. Now we can see in both sides there is sin y. We can cancel sin y with sin y. And after that we get m upon cos x is equal to n upon cos y. Now we can alter both the sides, and this gives cos x upon m is equal to cos y upon n. Now we can square both the sides. We can raise both sides to power 2. So by doing so, we get cos x upon m whole square is equal to cos y upon n whole square. And in the next line, we can open brackets. This gives cos square x upon m square is equal to cos square y upon n square. Since we want to prove this, so we have to convert the right hand side, cos square y. We have to remove this and bring here either cos x or sin x. Now in the next line, we can write cos square x is equal to m square. And in the right hand side, we can write, for cos square y we can write 1 minus sin square y. And this gives cos square x upon m square. Cos square x upon m square is equal to 1 upon n square into 1 minus sin square y. 1 minus sin square y. And in the next line, we can substitute this sin y by sin x upon m. Because from this equation, we get sin x upon m is equal to sin y. So let us substitute this with sin x upon m. And in the next line, it becomes cos square x upon m square is equal to 1 upon n square within bracket 1 minus, for sin y, we're going to write sin x upon m. So it becomes sin square x upon m square. And in the next line, we can write cos square x is equal to m square. Now we have to open bracket. 1 upon n squared into 1 is 1 upon n squared, plus into minus minus. 1 upon n squared into sine square x upon m squared is equal to 1 upon n squared m squared into sine square x. Now we are very close to this. In the right hand side we can substitute sine square x by 1 minus cos square x. So it becomes, in the next line it becomes 1 upon cos square x upon m square is equal to 1 upon n square minus 1 upon n square m square. For sine square x we can write 1 minus cos square x. Now we can see in both sides there is cos square x. So in the next line it becomes 1 upon n square minus 1 upon n square m square minus minus plus cos square x into 1 upon n square m square. And the left hand side doesn't change. It is cos square x upon m square. Now we can bring this part to the left hand side. So in the next line it becomes cos square x upon m square minus, when it comes to left hand side it changes its sign, so it becomes minus 1 upon n square m square into cos square x. And in the right hand side we have to write this part 1 upon n square minus 1 upon n square m square. Again we can continue here. From the left hand side, from these two terms we can take cos square x as common. So within bracket there remains 1 upon m square in the first term minus 1 upon n square m square in the second term. And the right hand side is 1 upon n square minus 1 upon n square m square. And in the next line we can subtract these two fractions. So it becomes cos square x into the LCM of these two is n square m square, or m square n square. When you divide this with this, quotient is n square into 1 is n square, minus when you divide this with this, the quotient is 1 into 1 is 1. And the right hand side also LCM is m square n square. So when we divide this with this, the quotient is m square into 1 is m square, minus when you divide this with this, the quotient is 1, and 1 into 1 is 1. And now in the next line we can write cos square x is equal to, this goes up, this goes down, m square n square upon n square minus 1 into this m square minus 1 upon m square n square. And we can see these two are equal, we can cancel them. And after cancelling them we get cos square x is equal to m square minus 1 upon n square minus 1. Therefore, cos square x is equal to m square minus 1. N square minus 1 into 1 is n square minus 1. Hence, this is equal to the right hand side. Therefore, it is proved. So guys, this much for today. Thank you very much for watching this video. If you like my videos, don't forget to like, share, and also to drop your valuable comment in the comment section. Bye bye. Take care.